Hey guys, welcome back to lecture series on Fourier transform. Already we have started lecture series based on the Fourier sine, cosine, Fourier and their inverse transform. So if you are interested to see this video, do check in my playlist. Okay, so in our today's video, I'm gonna explain to you all one of the question which is completely based on Fourier sine and Fourier cosine transform. Okay, so now onward we are going to solve similar example with the both method. Okay, Fourier sine and Fourier cosine. Okay, so these are the good example for our practice. Okay, yes, so let's get started our today's solution for the Fourier sine and cosine transform for the function f of x, which is equal to 2e raised to minus 5x plus 5e raised to minus 2x and x greater than 0. Okay, so we want the Fourier sine transform. Okay, directly apply the formula for Fourier sine transform. Okay, so for Fourier sine transform, okay, so we know that the Fourier sine transform it defined as a capital F suffix s. Okay, F suffix s over s. So you can take s or you can take lambda also. So which is f suffix s over s. Okay, we consider Fourier sine transformation over s, and it is defined as 0 to infinity small f of x. Okay, 0 to infinity small f of x sine sx dx. Okay, yes, so don't get confused about lambda and s. In most of the example we have yes, in some of the example are lambda are there. Okay, so we consider yes here for this example. Okay, now see that what we have given this example f of x 2e raised to minus 5x plus 5e raised to minus 2x. Okay, this one is our small f of x which is given, so you just have to replace this value over here and need to solve this integral further. That one is our required answer. Okay, yes, so replace small f of x here. Okay, so we are going to replace small f of x. So we going it integral, it look like 0 to infinity small f of x is a 2e raised to minus 5x plus 5e raised to minus 2x. Okay, this one is our required f of x. I written as it is over here. Okay, and sine sx keep as it is, sine sx dx. Okay, sine sx dx keep as it is. Now see that here we have exponential function, here it is exponential function, and it is a trigonometric function. Okay, so let's go for finding the integration for these two ones. Okay, so we are trying to multiply and expand this integral. Okay, you now see that how we have integral, as we have x, all the value for x which is 0 and bigger than 0. Okay, that means strictly bigger than 0, so integral it will remain same. We don't have to change this integral. We write as 0 to infinity 2e raised to minus 5x multiplied by sine sx. Okay, sine sx dx plus again multiply that sine sx to this term 0 to infinity. Okay, we can expand the integral. So as we have standard form of integral, it says that the integration of a plus b can be written as a integration of a plus integration of b. Okay, this one you need to know. Okay, so I'm applying this form over here for this integration. Okay, so 5e raised to minus 2x, 5e raised to minus 2x. Okay, 5e raised to minus 2x sine sx dx. Okay, sine sx dx. Now see that what I have done here. I just multiplied sine sx here and as well as here. Okay, yes, so as we have two constant here, we can take it is the outside of integral, and e raised to minus 5x sine sx dx, and again take that 5 outside here, e raised to minus 2x sine sx dx. Okay, yes, now see that this one we cannot solve by using by part of integration. Okay, for solving this integral we need one of the standard form for integration. Okay, so which says that integration of e raised to ax sine, okay, we write integration of e raised to ax sine bx dx. Okay, I already explained this form in my previous lecture. Okay, yes, so e raised to ax sine bx dx. Okay, this integration we write e raised to ax upon a square plus b square. Okay, we write this integration as e raised to x upon a square plus b square, okay, under bracket a sine lambda x, a sine lambda x minus b cos lambda x, b cos lambda x, okay. Yes, we write a sine lambda x minus b cos lambda x. Now see that whenever we have integral in the form of lambda, okay, so in such a case we consider it as the a sine lambda x plus b cos lambda x, okay. But instead of lambda we have yes here, okay. Yes, so we going to replace these values here. So in our next step we write e raised to x sine lambda x dx, okay. Instead of b I taken lambda here, okay. You can take b also. So already I explained the formula in the form of b, okay. So e raised to x sine lambda x dx can be written as e raised to x upon a square plus lambda square a sine lambda x minus lambda cos lambda x, okay. So you can take b instead of lambda also, okay, not an issue. As I have taken here just to avoid the number of calculations, so I just added lambda here, okay. Yeah, it is okay. So we go for applying this integral with this one and again this integral with this one, okay. So consider this integral first, consider this integral first and consider this integral second, okay. Solve this integral, put the value here. Solve this integral, put the value here. That means I'm going to solve first only, okay. So first what we have here first, to outside 0 to infinity, okay, to outside that constant to outside 0 to infinity e raised to minus 5x, e raised to minus 5x, okay, sine sx dx, okay, sine sx dx, okay. Yes, this one is our the value for integral, okay. Now see that we have to compare this value with this value, okay. E raised to minus 5x means e raised to minus e raised to ax. What is the value for a? So I'm going to write a as a minus 5, okay. How that a minus 5? Just compare e raised to minus 5x with e raised to ax, so we get the a as a minus 5 here, okay. So value for a is a minus 5. Now sine sx, what is the value for s? Which is a lambda, okay. S which is equal to lambda over here, okay. Yes, sx dx, okay. So dx it will remain same. So replace a as a minus 5, lambda as a and s as a lambda, okay. So wherever you will get the a, replace minus 5 and lambda replace s, okay. This is the replacement we want here in this form, okay. So e raised to ax, that means e raised to minus 5x, e raised to minus 5x denominated by denominator we have here a square plus lambda square. So a square means minus 5 square, it become 25 plus lambda square means s square, okay. 25 plus s square here, okay. Yes, just need to replace the value guys here, don't have anything difficult, okay. Yes, so what we go for, what we do, we write the next step, okay. Next values here, a sine lambda x, so minus 5 sine, okay, minus 5 times sine lambda sx, okay. Sx, what I have done, I just replace, okay, I just replace what s as a lambda. So lambda it is here, so I replace lambda as a s here, x as it is a which is equal to minus 5 here, sine here, okay, minus what is the value for lambda? S cos x, okay. This one is complete bracket. Now see that I applied this integral, okay. So now see that these two integration outside here, this constant, don't forget these two, okay. That means this 2 it is outside for this integral, so that 2 it will remain same under integration, expansion of integration we have here, okay. Yes, now so as we have integral 0 to infinity, so we have to apply limit 0 to infinity also, okay. So apply limit 0 to infinity here. So we are going to apply limit 0 to infinity, okay. Yes, so where we are going to apply limit, wherever you get x, okay. As we are taking integration with respect to dx now, so replace only x as a infinity and replace x as a 0, okay, as we have integral 0 to infinity, okay. So let me replace here, that I am solving this one, this first part I am solving here, we are going for second part later on, okay. So first of all put infinity. Now see that whenever you put infinity instead of x is infinity, okay, that means e raised to minus 5x. E raised to minus 5x can be written as denominator as e raised to 5x, okay. So I am explaining this term, okay. E raised to minus 5x can be written as 1 upon e raised to 5x, and when x is infinity, that means e raised to infinity, and it become 1 upon infinity. And 1 upon infinity, we know that what is the value for 1 upon infinity is 0. So if you replace infinity instead of x, okay, if you replace infinity instead of x, we get the entire term 0. Okay, now what is our next task? Minus. Okay, one entire terms gives us a 0. Okay, outside we have 2 as it is. Okay, minus, replace wherever you get the x as a 0. E raised to minus 5x means e raised to 0, which is a 1. Okay, 1 upon 25 plus a square, 25 plus a square. Okay, we cannot change a square, okay, as it is a completely constant with respect to dx. Okay, yes. So under bracket minus 5 sine sx. Okay, minus 5 sine sx. When sine x goes to 0, we replace x as a 0. So sine 0 is a 0. 0 into minus 5, it is a 0. Okay, yes, minus yes minus yes keep as it is, cos yes into 0. Cos yes into 0 means cos 0. Cos 0 gives us the value 1. Okay, yes. So what we go for next, so 2 keep outside. Okay, that minus yes and minus 1, it gives us the plus yes value upon 25 plus yes square. Okay, so this one is our required part. Okay, this one is a solution for our part first. Okay, so as I consider here part first here, so replace this solution here only. Okay, yes. Now similarly I'm going to find out the second part here. Okay, as it is not possible to find out the solution here, we don't have sufficient space, so that's why I'm taking the solution separately out here. Okay, yes. So let's go for the second solution over here. Okay, so what we have, second integral. I'm solving second integral now. Okay, so second integral says that 0 to infinity. Okay, second integral is 0 to infinity 5 e raised to minus 2x, 5 e raised to minus 2x, 5 e raised to minus 2x sin sx dx. Okay, sin sx dx. Okay, I'm solving this second integral now. Okay, yes. Now see that as 5 it is a constant now, take it outside. Okay, 5 it is coming outside. Now compare this form with this standard integral. Okay, e raised to ax sin lambda x dx. Now we get the a as a minus 2. Okay, a which is equal to minus 2. Okay, e raised to minus 2x now, that means e raised to x, a as a minus 2. Okay, sin lambda x and sin sx. Okay, so we get the lambda which is equal to yes. Okay, that means this lambda which is equal to yes. So replace these two values in this form. Okay, so you will get the simplified form of our integral. Okay, yes. So let me take that 5 constant outside from the integration. So 5 outside here under integration 0 to infinity e raised to minus 2x sin sx dx. Okay, which is equal to a is a minus 2, lambda is a yes. Okay, yes. So we replace these values here in this form. Okay, this simplified form. So e raised to ax, that means e raised to minus 2x. Okay, e raised to minus 2x upon denominator what we have, a square plus lambda square. So minus 2 square, it gives us the value plus 4. Okay, minus 2 square means negative term square, it always positive. Okay, minus 2 square, it gives us the plus 4 plus lambda square. What is the lambda square? Means e square. Okay, yes, 4 plus e square. Under bracket what we have left here with the value a sin lambda x. Okay, that minus 2 sin sx. Okay, minus 2 sin sx. What I have done, a sin lambda x, lambda replaced by s. Okay, minus 2 sin sx. Okay, yes. And now next part, what we have next part, minus lambda cos lambda x. Okay, so minus s cos sx. Okay, minus s cos sx. Okay, I hope you all have understood this one, how I have solved. Okay, just need to replace minus 2 and s in our given standard form. Okay, yes, that form gives us the value. Okay, so now see that we have to apply integral over 0 to infinity. Okay, and outside we have 5 here. Okay, 5 outside this in bracket. So keep 5 as it is outside. Okay, e raised to minus 2x upon 4 plus s square, 4 plus s square, and under bracket minus 2 sin sx. Okay, minus 2 sin sx minus s cos sx. Okay, bracket complete, and apply integral 0 to infinity. Okay, apply integral over 0 to infinity. Yes, so now see that whenever we have infinity, obviously e raised to minus 2x gives us the value 1 upon infinity. 1 upon infinity means entire term it goes to the 0, okay. So 5 outside, first of all when we replace infinity here, it gives us the 0. If this one is 0, so entire bracket gives us the value 0. Okay, yes, now we have a remaining chance to replace 0 instead of x. We are replacing only x, guys. Why? Because integral over dx it is there, so replace only x wherever you get the x, okay. So replace only x as a 0 to infinity. I replace infinity, so I got the entire term 0. Now next task to replace wherever you get the x as a 0, okay. Okay, so e raised to minus 2 into 0, it means 0, e raised to 0 which is 1, okay. So we write 1 upon 4 plus s square, okay. Yes, minus sign it is there, 0 minus 1 upon 4 plus s square, because we take infinity minus we take 0, okay. So 0 minus 1 upon 4 plus s square, okay. So now what do? We replace x as a 0 now, okay. So see that here minus 2 sine 0, sine 0 is a 0, okay. Under bracket we write this step as a 0 minus s cos s into 0, cos 0 1, okay. So it remain these values, okay. So minus it goes to plus, so we write 5, okay. We write next step 5 under bracket, okay, s upon 4 plus s square, s upon 4 plus s square, okay. S upon 4 plus s square, this one is the second I2, okay. This one is the value for I2, 5 into s upon 4 plus s square. Now see that I got the I1 over here, okay. I got the I2 over here. So this one completely, this one represent as the Fourier sine transformation, okay. Fourier sine transform. So replace I and I1 and I2 here in this integral, okay. So let me write how the solution it is coming, okay. So let me take this solution to the next step. So in our next step we write Fourier sine transform over s, 2 into under bracket s upon 25 plus s square plus 5 into s upon 4 plus s square, okay. This one is our required Fourier sine transform, okay. So as I have taken this example for Fourier cosine transform also, so we go for finding the Fourier cosine transform as well. So in our next step we go for finding Fourier cosine transform, okay. Fourier cosine transform, and Fourier cosine transform can be found by fc of s, okay. Capital F suffix c of s can be represented as a Fourier cosine transform over s, okay. And it defined as the integral 0 to infinity small f of x cos sx dx, okay. Yes, so replace small f of x here, okay. 0 to infinity, we have the small f of x given 2 e raised to minus 5x, 2 e raised to minus 5x plus 5 e raised to minus 2x, 5 e raised to minus 2x, okay, multiplied by cos, okay, sx dx, okay. This one is our Fourier cosine transform over s, okay. Yes, now let's go for multiplying similarly as we done it in our Fourier sine transform, okay. So multiply this one here, and take constant outside so that we can apply standard format for solving this one, okay. Yes, so two constant outside, integral 0 to infinity, okay. Two constant outside, e raised to minus 5x, okay, e raised to minus 5x cos sx dx, cos sx dx, okay. So I took this step here plus integral 5 constant outside, 0 to infinity integral, okay, e raised to minus 2x cos sx dx, okay. So these are, we have two different integrals. Now see that we have to apply some other result for finding the solution. In my the previous part I applied e raised to x sine sx dx, okay. So in our next part we go for the another result which is defined on the cos, okay. Yes, so we take e raised to ax cos bx dx, okay. So integral you can take anything, okay. Yes, so in our next step we will take e raised to x cos bx dx. It can be written as e raised to x upon a square plus b square, okay. Yes, and we apply the result over here, a cos bx plus b sine bx. Okay, so we apply this result over here. Okay, a cos bx plus b sin bx. Now compare these two results for this one and replace the value, revert it back. Okay, yes, so I'm going to solve first integral first. Okay, first integral this one, second integral this one, and I'm going to replace these values over here. Okay, so we'll get the required answer. Okay, so a raised to minus 5x cos sx dx. Okay, let's work for the first. Okay, for first solution, a raised to minus 5x integral e raised to minus 5x integral over 0 to infinity. Okay, cos sx dx, cos sx dx. Okay, now see that if we compare this with this one, we get the a as a minus 5. Okay, what is the e raised to ax, which is equal to e raised to minus 5x. So a as a minus 5 cos sx and cos bx. Okay, so b which is equal to s. So replace these values over here. Okay, e raised to minus 5x upon, okay, a square plus b square. So minus 5 square, it is 25, plus b square, which is a s square. Okay, yes, a cos bx. So minus 5 cos sx plus b. What is the value for b? S sin sx. Okay, this one is our next part for this integral. Okay, so as we have integration over 0 to infinity, so apply integral over 0 to infinity then. Okay, so now we can see that e raised to minus 5x, that means e raised to minus 5x when power infinity. Okay, let me write e raised to minus 5x first. E raised to minus 5x can be written as 1 upon e raised to 5x. Okay, and as we have integral over dx, so we are replacing only x as a infinity and 0. Okay, so replace x as infinity. So if we replace x infinity here, 1 upon e raised to infinity, and e exponential term e is having value 2.7 something. Okay, yes, so that means 2.789 some to the power infinity means 1 upon infinity. Okay, so which is 1 upon infinity, which gives us the value 0. Okay, so first of all we got the value for entire bracket, it is 0. Okay, 0, entire bracket is 0 when we multiply, put infinity as x. Okay, this 0 means entire bracket 0. Okay, now replace instead of x as a 0. Okay, so e raised to minus 5 times 0, it is 1. Okay, and 25 plus s square. Okay, minus sign as it is. Okay, under bracket minus cos 0x, cos 0 it is 1. Okay, so we write minus 5 only, and the sin 0 it is a 0, so plus 0. Okay, so we have here minus 5. Okay, we have here minus 5, that minus 5 it is left here. Okay, minus 5 cos sx, it is gives us the value 1. Okay, yes, so now see that negative gives us the positive. We left here with the value 5 upon 25 plus s square. Okay, yes, so now see that this one is the only value for I1. Okay, that means 2 it is multiplicand here for I1. 2 I didn't take it here downside, so keep 2 as it is, replace I1 here instead of this integral. Okay, yes, plus 5 keep as it is, take second integral. Now I'm going to use second integral over here. Okay, so now see that instead of minus 5 we have minus 2. Okay, and left over all the process it will remain same. So in our part I taken I2 second integral over here. Okay, so I'm going to apply this standard formula for finding this integral. Okay, yes, e raised to x cos bx dx can be written as e raised to x upon a square plus b square. Okay, e raised to x means I got the a as a minus 2, b as a s. Okay, b which is equal to s. All process it will remain same. Okay, so I hope you all have understood my previous part. Okay, we have to replace reuse it as it is like a previous one. Okay, yes, e raised to ax, that means e raised to minus 2x as it is. Okay, e raised to minus 2x upon a square plus b square, that means 4 plus s square. Okay, minus 2 square plus s square. Okay, 4 plus s square, under bracket we have the value. Okay, a cos bx minus 2 cos sx minus 2 cos sx. Okay, yes, minus 2 cos sx plus s sin sx. Okay, so what we have here, b sin bx. Okay, means s sin sx. Okay, s sin sx. Okay, s sin sx, and bracket complete, and we have integral over 0 to infinity. Okay, apply the limit 0 to infinity then here. Okay, so if we put infinity, this step gives us the value 0. Okay, 0, how it is coming I explained already here. Okay, yes, this 0. Similarly, so if you put infinity here, this step goes to 0, minus put instead of x as a 0, e raised to 0 it is 1. Okay, 1 upon 4 plus s square. Okay, 1 upon 4 plus s square, under bracket minus 2 cos sx. Okay, minus 2 cos sx. Okay, So what is the value for yes x? Okay, yes x means 0x. That means it is uses the cos 0. Okay, cos yes into 0 means it is a 0. Okay, yes, plus yes sin yes x means sin 0 0. That means yes into 0. Okay, bracket complete. Okay, now see that. So what here, that minus and minus gives us the plus 2. Okay, 4 plus s square as it is denominator. Okay, yes, and cos 0 it is 1, and this also 0. Okay, so we have integral second. Okay, second integral I2. I got the second integral I2 over here. First integral I1 over here. Replace I1 and I2 in our given integral. Okay, 2 times integral I1 plus 5 times integral I2. Okay, let me write the Fourier cosine transform. Then Fourier cosine transform over S can be written as 2 times I1 integral. Okay, so 5 divided by 25 plus S square. Okay, 5 divided by 25 plus S square, and plus 5 times I2 integral. Okay, I2 integral is a 2 divided by 4 plus S square. 2 divided by 4 plus S square. Okay, this one is our required. This one is our required Fourier cosine transform. Okay, I hope you all have understood how to find the Fourier cosine transform. It is one of the easy, guys. Okay, for your reference you can refer my entire solution here. Okay, so if you have any doubt, difficulty, any confusion in my entire solution, guys, let me know in my comment section. Okay, just putting one single video, there is lot of efforts. So I hope you all have understood my today's lecture, guys. So thank you everyone, thank you so much for my today's lecture. So any doubt, difficulty, let me know in my comment section. So thank you everyone.